All right, here we have a problem. It's a buoyancy problem. So we have somebody is partly submerged in some fluid. We're given the average density of the person, and we're wondering what the ratio is of the part which is a part of your body which is submerged versus your total volume. So let's draw a very crude picture. So here is our person in water. Only part of the body is submerged, so that's this part that I've just circled here. So we'll call that volume V sub. Okay, and then there is the total volume is just the whole person, and we'll call that V total. Okay, so this is our problem. Let's start with a free body diagram for this person. So this person is floating, and so that means that the buoyancy force is going to equal to the weight. So let's draw our free body diagram. Here is our axis. Now the forces are just going to be in the y direction, so I'm not going to worry about the x direction. And if we have our person, which is represented by this dot, there are just two forces acting on him. There's his weight or her weight, and there's the buoyancy force. Now these are going to be equal in magnitude because this person is floating. He or she is in equilibrium. So here's our buoyancy force and our weight. Okay, so Newton's second law tells us that the sum of our forces is equal to 0. So we have the buoyancy force minus the weight should be 0. So this means that the magnitude of our buoyancy force should equal the weight of this person. So the buoyancy force, well, there's one thing we have to note, and that is that mass can be found from the volume of a object and its density. So mass is equal to density times volume. So the weight of our person is equal to the mass of our person times the acceleration due to gravity, and we can write this as density of the body times the total volume of the body times g. And the buoyancy force is equal to, it's equal in magnitude to the weight of the volume of water which is displaced, which is equal to the volume of the part of the person which is submerged. So we can write this as the density of the fluid times the volume of the submerged person, which is equal to the volume of the water which is displaced, times the acceleration due to gravity. Okay, so let's look at this equation. The g's cancel, and I can solve for the fraction of the volume of the submerged part of the person over the total volume of the person. So it's V sub over V total. And this is equal to the density of the body divided by the density of the fluid. There. So that's our equation. This is the ratio here that we're asked to find, or the fraction that we're asked to find. So we can go ahead and do some calculations. So for part A, the density of fresh water is just 1,000 kilograms per meter cubed. So our ratio V sub over V total is equal to the density of the body, which is given in the problem, 995 kilograms per meter cubed, divided by the density of the fluid, which is just 1,000 kilograms meters cubed. Notice that all of my units cancel, and this is just 0.995 or 99.5%. So for part B, we do the same thing, and the ratio is just the density of the body, 995 kilograms per meter cubed, and we divide by the density of salt water, which is given above. It's 1,027 kilograms per meter cubed. And when you plug these numbers in your calculator, you should get something like 0.969 or 96.9%. So it's going to be, the fraction is going to be slightly lower. So it means you're going to float better in salt water.